Okay, so today I'll be talking about variable types and evaluating expressions. So during the last class, I talked about being able to um, basically the basis of writing a class, and also the basis of class design, and also method initialization in regards to writing the method signature. But today I'll be talking about the two basic important topics of how to modify the body of a method and actually focus on writing the body of the code. So one of these important topics to know is variable. And for the most part, we'll be using what we call primitive variables. And the few types that we should focus on are Boolean variable types, characters, integers, and floating variable types. And for integers, we'll be focusing on the integer type, and for floating, we'll be focusing on double. Yeah. So what floating basically means, as we can see from the examples of our primitive types, integers can be 0, 1, or any positive or negative number. There is a bound for an integer. It cannot exceed a really large number, but for the purposes of our class, we would treat integers as covering all the integers that we'll be using. A double will cover anything in between an integer and a fraction, as a double can be used to represent numbers with decimal points after them. And this can be in the form of a fraction or like a decimal or a rational number as well. For example, we have 0.7 or 192.4, or a negative number with a decimal place in it as well. And also, when we represent an integer as a double, when we initialize it as a variable type of double, it will always just add a 0.0 at the end, and we have to be careful with that. But also, for the most part, it will be similar to using a variable integer. For car represents character, and it's another important variable type to talk about. The important thing to know is that a bunch of characters make up a string, and a string is your usual text, like I don't know, like a name or something else. Like any word is considered a string in Java, and strings are technically an array of characters. So characters make up strings, and characters can be any character on your keyboard, for example, an A or a B, or it can also be something like an asterisk or a slash or backslash or something like that. For another primitive type to know is the Boolean type, and the reason we need to use Boolean is to a Boolean helps us to understand the logic behind the code, and true and false are the two Boolean types. For example, when in the future, if we are writing a for statement or something like that, and we need to write a condition for a method, we will use a Boolean, because the conditional statement would have to evaluate to either true or false. And given the conditional statement, the for loop after it or the if statement after it would be able to be run. So these are the examples of the primitive types that we're talking about. And yeah. So I talked about strings earlier. A string is a collection of characters, and it's important to know that strings are not primitive types. Strings are considered objects in Java. However, as they are used very commonly, they will be treated similarly to a primitive rather than object. For example, when we define a new string, instead of defining it like a variable, as we see here, we would just define it like a primitive with the classic variable type, name of variable, and then equals to initializing the statement. And also, the important thing to know about strings is that we can manipulate it using built-in methods. And some of the built-in methods are like the length of the string or something like that. But some of the other built-in methods in regards to strings can be found at the link I posted. And since I will be posting these slides, you can look at that, I guess. And please don't spam my chat because I am looking at it currently and I don't appreciate that. So now that we know the variable types, we have to know what a variable is. Yeah, I know I can kick people out, but I don't want to right now because that will take up class time and I have a lot of stuff to go through. But just know that I can, I guess. So what a variable is a variable stores a value in the memory of a computer to be used later on. And for example, I found a picture that represents this well. It's, for example, if we define an integer count as 100, the integer is stored in what we call a container in this memory of the computer. And here we can see that a container named count is holding a value 100. And this allows us to store any values inside. And how we use a variable in Java is that we have to first declare it with the name and type. For example, integer count, and then semicolon would be declaring it. And then we have to initialize it by giving it an initial value. For this instance, count is given an initial value of 100. So when we declare it, we have a container called count and is able to hold a certain type of variable. And after we initialize it, the container will hold a value of the specific variable type. And then we can utilize a variable in an expression or print statement by calling upon it. And that's the main purpose of a variable. It allows us to store anything that we calculate within a method. And instead of having to calculate things over and over again, we can just call upon it repeatedly. And that's what makes variables important. So someone asked if we're going to do any coding today. And I actually have planned an activity at the end of class after we go through this lesson. So hopefully we will actually do some coding today. And the main purpose of this is that we talked about methods and class design last week. And by talking about variables and some evaluating expressions, the basics of that, we'll be able to write simple methods and utilize objects in the preferred way of object-oriented programming. So hopefully we will be able to do that. So do you guys have any questions in regards to variables? Basically, variables are just a value that we define to hold in place in the memory, and we can use it to store information that we calculate. So does anyone have any questions about that? If not, I guess I can go on. No questions. I don't see any. So pretty good, I guess. I don't know. I thought I might have gone a little fast in describing variables, but I guess none of you guys have any questions about that. So I can go on then. So after we initialize a variable by defining the variable type and naming it, and also giving it an initial value, we can use an assignment statement to change the value of a variable. So the assignment operation uses the equal sign, and what it does is that when we call upon the variable name, like num1 for instance, and we set it equal to a different value, it changes the value assigned to the variable to a different value. And also anything to the right of the equal sign that we assign to the variable can be an expression as well, and the computer will automatically calculate the expression to the right. And it says that if there is expression to the right, it is evaluated and then assigned to the variable. And this basically allows us to do calculations with variables and also change the value of a variable within a method. And we can also change a value of a variable in regards to its initial value. For example, by using the plus plus sign, if we set num1 equals to num1 plus 1, that would just add 1 to the current value. So you can, when assigning a new value to a variable, you can call upon its original value. But one thing to be careful of when assigning a new variable to a variable is that it must match the variable type. And what I gave here is an example of assigning a value that does not match the variable type. And it's what we call an illegal assignment. So for example, if we define a variable as an integer type and name it num, we cannot set num to Bob because Bob is a string, a word, and a word is not part of an integer. So we cannot do that. So assignment statements allow us to change the value of variables, and we can use that when we are writing a method. So does anyone have any questions on that? No? Okay, that's good. So an example of what a good habit to use when understanding variables is the declare initialize use process of using a variable. First, we must declare it. So if we declare two variables here, for instance, we call it length and width, we can use length and width to calculate a lot of things in regards to like a rectangle. I don't know, for instance, you can find the perimeter of a rectangle or the area or something. So we would define two integer values of length and width. And using these variables, we can create a method to calculate the area or the perimeter of a rectangle. And then the next step after defining the variable, defining the variable, we have to have the variable type followed by the variable name and then the semicolon. After every line of code in Java, you always have the semicolon. So that's just something you have to remember about coding. It lets the computer know when a line of code ends. So I guess that's helpful. And then after declaring a variable, we must initialize it. What initialize means is that we assign an initial value to the variable. For instance, if we don't change the length and width of a box, we could set the initial value of the box length to be 5 and the width to be 11, as we can see here in our example. And then what this does is that when we call upon the variables in this instance, the memory of the variable will refer us to what we initialize the values of the variables to, and then we can use this in our function. And then lastly, we must utilize the variables because that's the reason why we're creating them for. So in this instance, my example is using length and width to calculate the area of a box. And so I'm simplifying it a bit here, but what I'm doing is I create another variable called area, which is also an integer type. And I set it equal to length times width because that's the formula for area. And the equal sign here is the operation we use for an assigning statement, like I mentioned earlier. So what we do is that we assign this formula for area to the variable area itself. And as we can see, aside from the coding part behind it, here's a visualization of the process here itself. Length and width would be two variables important to calculate the area, because we know that area is equal to length times width in a rectangle. And when we initialize the values of length and width, the computer calls upon those values to calculate the area for you. So does anyone have any questions in regards to my example of using variables to calculate a tangible object? You can type to me if you have any questions. I have the chat open. I hope you guys are able to understand that, because it's pretty simple, I guess. Okay, so no questions? I missed the last class. What were we looking at, Charles? So the last class, I basically went over class design. I posted the class slides onto the Google Classroom, so you can review it there. Basically, we talk about the most important thing of last class is that we talked about how classes and objects work and their definitions, and we also talked about how to initialize a method, and that is something that we will be practicing today at the end of class. And sorry I'm late. I guess that's okay. I'll be posting the video recording of this slide, of this class and the slides onto Google Classroom afterwards. All right, so I guess I will go on. Hopefully you guys are able to understand variables and the declare initialize use process behind them. This is, okay, yeah. So arithmetic operations. In Java, as I mentioned earlier, like setting an expression equal to a variable with an assigning statement, we can use arithmetic operations. And the arithmetic operations follows the same order of operations that you use in math. And hopefully you guys are somewhat qualified in the math area subject. So when we look at arithmetic operations, Java does modulus, division, and multiplication before any subtraction, addition, and subtraction. And some of the symbols are modified a bit. For instance, addition and subtraction are the same, but multiplication use the asterisk instead of the X or time symbol, and division use the slash. And modulus remainder, modulus, the percent symbol, is another important Java arithmetic operation to know. And basically what it means is that it yields the remainder of one number divided by another. For instance, 7 divided by 3 would be 2, remainder 1. So when we do 7% 3, the remainder, it would give the remainder of the operation of 7 divided by 3. Since the remainder is 1, 7% 3 would equal to 1. And since 8 is evenly divided by 4, it would have a remainder of 0. So that's just something that I'm going to explain real quickly, because I hope you guys should know what a modulus and remainder are already, but I just wanted to go that just in case that definition wasn't very clear. And another thing to be careful of is that a value assigned to an integer variable is automatically truncated. Since an integer variable can only store integer values, it cannot store like a fraction or any number with decimal places. So something like 9 divided by 4, which is equal to like 2.25, the 2.25 would be truncated and the value 2 would be stored in total. And for something like 7 divided by 4, which is equal to 1.75, the 0.75 will be truncated and the value 1 would be stored in total. REPL can replace it, right? Replace what? Not sure what that question is. I'm pretty sure for, I don't know, unless you don't define it, I'm pretty sure, I don't really understand that question very well. Do you have a better way to phrase it? In general, we have to define a variable in order to assign a value to it. And unless we define a variable as a double or a float, REPL can replace BlueJ, right? For now, REPL can replace BlueJ because we aren't really getting into like the graphics and stuff, but I still want you guys to get BlueJ, which I have been reiterating during my classes, and it's actually pretty simple to do so. So I don't see why you guys shouldn't. Although I understand that some of you guys have computers that might not accept BlueJ or something like that, so that's okay. So yeah, I understand it's hard to download. Truncate, what truncate means is that anything after the decimal place is removed. For example, since 9 divided by 4 is 2.25, the 0.25 is after the decimal place, so it is just removed. And 2 is remaining. Since an integer has to be an integer. So decimal places and anything after it are simply removed. Okay, so I'll move on now. So here's some practice to understand how like Java computes things. So 2 plus 3 is pretty simple. It's equal to 5. Everyone should know that. But when one of your numbers is defined as a float or a double and has a decimal place after it, the automatic result after it that Java would output would be in the variable type of a float. So 2 plus 3.0 would output a float result unless you assign it to an integer value, in which case Java would automatically convert the float value to the integer value by truncating it, like I said before. And here we have two floating variable types. So the decimal place remains. But if we change these two variable same numbers to integer types, then the value, the 0.5, as I said before, is truncated and removed. So it would be 7 divided by 2 is 3. We also see some examples of modular and remainder being used. Since 5 divided by 2 has a remainder of 1, it would be the same as 1 plus 6 is equal to 7. And also, since Java uses order of operations, for this, it would be 2 times 3 divided by 5. 2 times 3 would be equal to 6. 6 divided by 5 would be 1.2, but the 0.2 is truncated because of integer variable types. So it would be simply 1 plus 1 is equal to 2. And for here, because of order of operations, 6 divided by 7 is equal to 0 because of integer types being truncated, so it would be simply 0. For here, we see that 6.0 divided by 2.0 is 3.0. But even though the last number is an integer, because the previous evaluated expression is a float, the end result will still be a float. For here, 8 divided by 3 is evaluated first, and 8 divided by 3, since both are integers, would be equal to 2. Since 8 divided by 3 is 2.666, repeating, and the 0.666 is truncated to give a 2. So it would be 1 minus 2, which is equal to negative 1. And for this one, Java would, by order of operations, would evaluate this first. So 4 divided by 4 would be 1, and then 1 divided by 4 it has a remainder of 1, multiplied by 4 is 4. So it would be 4 plus 4 is equal to 8. And then here are some other examples. So I just gave some examples of how expressions are evaluated in Java, so that if you guys have any questions, hopefully these cover all the most complicated scenarios that you'll be encountering. And since I'll be posting these slides, you can view these afterwards. So does anyone have any questions about that? I know I went pretty fast, but these are just examples of how to evaluate expressions based on the rules that I outlined earlier. All right, so you guys don't have any questions? That's great. Last thing I want to talk about is string concatenation. So we talked about how we can evaluate expressions using numbers, for example, integers or floats or numbers with decimal places after it, but also we can apply some of these order of operations to strings, which are words. We can utilize additioning strings from here. For example, string A is equal to comp plus psi. So we just concatenate both of these strings together to form comp psi. And then once a string is added to anything, the result is a string. So for example, if we have string D comp plus 3 plus 4, comp plus 1 plus 2, 1 and 2 are considered strings after comp is here. So it would be comp 1, 2, but there's this addition or subtraction or something before the variable, it will be evaluated. So 1 plus 2 before a string would first be evaluated to 3 and then concatenated to the string. And order of operations with parentheses are also honored by Java. So we can do something like 3 plus 4 at the end of assigning a variable to a string, and we can do that. So with this in mind, I want to give you guys an assignment to create an animal class with at least 3 attributes or 3 variables assigned to it. And want you guys to initialize the 3 variables in the default object as I outlined before. And also to write 2 methods, one that prints all the attributes of the object and one method that modifies a certain attribute of the object by using an assigning statement to change it. So this combines, we've talked about this class in our last class, and hopefully you guys can do that. But if not, I will be doing it currently, and you guys can follow along to see if you guys are doing anything differently. So I guess I'll do it right now. So what an animal class is, like as we talked about class, a class is a group of objects. So we have something like a car would be considered a class, or like a parrot or a frog or any type of animal would be considered a class, because there are many types of objects within the class itself. So new project. So using BlueJ, I'm using BlueJ. You can probably use REPL for this, but I'm not sure. I would create a new project by pressing project and new project, and I would name it something, I don't know, method practice. That should work. And then afterwards, I would create a new class, consider it any type of animal. I don't know, I'll do BlueJ because we are using BlueJ, and that's pretty funny. Yeah. So BlueJ is my class, and we create a class. We can double click on it to edit the code behind it, and this pops up. This is pretty overwhelming, obviously. The only thing we've done here is during our first class when we did the hello world example, but anything with that's blue and commented out, you can ignore. So the first thing we have to do is to initialize, is to define 3 attributes. So what would be 3 attributes of, say, a blue jay? I don't know. We can do miles flown. So a bird like a blue jay flies, right? So one of its attributes could how much miles it has flown within its entire life. So we can have a variable for that. Another variable could be its name, because birds have names in my world, hopefully. We can also give something else, I don't know, to the bird. What would be a variable to give to a bird? Age. So that's the first part of the assignment done. I create a class and I defined 3 attributes to the class, as I say here. And let's see. Hopefully I can. How do you download BlueJ? You search BlueJ on Google and you download from the first link. Bird 1, bird 2, bird 3. Okay, yeah. So I'm pretty sure it's miles flown. I'm not sure about that. The next step is to initialize these variables for a default object. What a default object is, when you create an object of the class, it would automatically be a default object unless you change it using a method. So for our default object, when a bird is born, it hasn't flown any miles, so miles flown would equal to 0. Age would also equal to 0. And for my world, baby birds are called Bob, because Bob is a good name. Be like Bob. So using the example of a method here, we can create the first method, Apple App Store. No, it is not. You can search BlueJ on Google, and you can download a MacBook version if you're using a MacBook. Int. What about Joe? Joe is an inferior name. So public, as we wrote in our last class, method that outputs stuff doesn't really take in any variables. So it's writing the method signature for this would be display. We would have the return type void because it outputs a print statement, so it would be void, and it would be something like display attributes. It would be the method name, and then that, and then put your code here. See, BlueJ wants you to put code there, so we put code here. We just do something simple like and we copy this because copying is good. And we output all the attributes. I'm running out of time here, but I'll be able to finish. And then the other method I wanted you guys to create is to change the attribute. In this case, I'll do a simple thing like void will return the bird's new age after its birthday. So I'll just call the method birthday. So what birthday does is it increases the bird's age by 1. So we use what we went over earlier today with the age equals to age plus 1. And that increases the age by 1 by using an assigning statement. And then we have to return the bird's new age. We use return age. So all this compiles, which means it's good. And we can test out here. So we right click and we create a new object. So we create a baby bird. And right here, we can display the bird's attributes. So its default attributes are milestone 0, age 0, and name Bob. But if we can change the variable of age with our function in birthday, it would return 1 because the baby bird's age increases by 1. Then when we display attributes again, the age attributes would output 1. So we can see that our code here works. So that's the assignment I wanted to give you guys today. And you guys can view how I did it on Classroom. Because I'll be posting the video of this, and hopefully you guys can follow along and do the same assignment yourself. It's relatively simple, and I'm pretty sure I've run out of time, so that's that.